So now we are card, I think this is card number 114. My toolbar is blocking it. But card number 114, Pythagorean Theorem, which all of you should be familiar with. In a right triangle, the square of the length of the hypotenuse is equal to the sum of the squares of the lengths of the sides. So a squared plus b squared equals c squared. And we know c squared is the hypotenuse. So find the missing measure using Pythagorean theorem. We need to find x. In this case, x is the hypotenuse. So I can say this is A and this is B. It can be the other way around. It doesn't matter. But I know that 4 squared plus 7 squared is equal to x squared. 4 squared is 16. 7 squared is 49. That equals x squared. So then I have 65, is equal to x squared. I'm going to take the square root of both sides. So the square root of 65 is equal to x. And I cannot simplify the square root of 65. So we will just leave it as the square root of 65. Okay? So pretty straightforward. We know Pythagorean theorem. This is probably the only thing we really remember from middle school math. So here's another one. Find the missing measure. This time, my x is one of the sides. So the only thing I know for sure is that 12 is C. 8 can be A or B. It doesn't matter. I'm going to call it A. So we have 8 squared plus x squared is equal to 12 squared. And so then 8 squared is 64 plus x is equal to 144. I'm going to subtract 64 from both sides, and I'm just writing this out for the people who just might need to see it. And so then x is equal to 14 minus 6 is 80, right? And so then, that is x squared is equal to 80. I'm going to take the square root of both sides, so x is equal to the square root of 80, which I can simplify because 80 is 10 and 8. 10 is 5 and 2. 8 is 2, 2 and 2. So I have a pair of 2's and a pair of 2's. So x is 4 root 5. And so again, this is definitely a review, and I feel like you should be comfortable with finding the third side using Pythagorean theorem. So a Pythagorean triple is a set of 3 non-zero whole numbers, a, b, and c, where a squared plus b squared equals c squared, but they are specific. So the most common Pythagorean triple that we know is 3, 4, 5. And so then you can take 3, 4, and 5 and multiply them by x to get a series of Pythagorean triples. So 3, 4, 5 times 2 gives me 6, 8, 10. Times 3 gives me 9, 12, 15. So you can multiply it by any number. That will still be a triple. The other popular triples are 5, 12, and 13. 8, 15, and 17, 7, 24, and 25. So at least the top row, those are the triples that you want to remember because those are the most common and they will save you a lot of work if you can automatically recognize them. So this example says, use a Pythagorean triple to find x, explain your reasoning. So I know that I have x, 24, and 26. And so this is some form of a triple. So then I can say to myself, okay, what number is both divisible by, or both 24 and 26 divisible by? First thing that pops into my head is 2. So I'm going to divide both of these numbers by 2. I don't know why I did that division sign. It just didn't make a fraction. But I end up with, we'll call it y. And then 24 divided by 2 is 12. 26 divided by 2 is 13. And then I can say to myself, oh, that's a popular triple that I know. So then what triple is that? That triple is going to be 5, 12, 13. So if I have 24 and 26, they were both multiplied by 2. Then that means that 5 needs to be multiplied by 2. So if I multiply 5 times 2, then I'm going to get 10. So then my triple is 10, not 12. 10, 24, and 26 from my 5, 12, 13 triple. So then your card number 115 is just the converse of the Pythagorean theorem. If the square of the length of the sides of the longest side is equal to the sum of the squares of the length of the other sides, then the triangle is a right triangle. So if c squared is equal to a squared plus b squared, it's a right triangle. But you can use that same piece of information, that same relationship between a squared, b squared, and c squared to tell you how to classify triangles as well. So your card number 16, is the Pythagorean inequalities theorem for acute triangles. So if the square of the length of the longest side of a triangle is less than the sum of the squares of the length of the other sides, then the triangle is acute. So if you have a squared plus b squared, and if a squared plus b squared is greater than c squared, then it's acute. Sometimes the way they do this confuses me. So I like to write a squared plus b squared is greater than c squared. So if your sum is greater, then it is going to be an acute triangle. Again, if your sum of the two sides is greater than the longest side, then it is an acute triangle. You can use that same knowledge to figure out an obtuse triangle. So if I have a squared plus b squared is less than c squared, then my triangle is going to be obtuse. Again, if a squared plus c squared is a squared plus b squared is less than c squared, then it is obtuse. So let's look at some examples, a couple of examples to classify some triangles, and then we will be done. So determine whether 9, 12, and 15 can be the measure of the sides of a triangle. If so, classify the triangle as acute, right, or obtuse. Justify your answer. So what we want to start off is what's going to be A, what's going to be C, what's going to be B. So I'm going to have 9 is equal to A, 12 is equal to B, 15 is equal to C. Your largest number always has to be C, so 15 is C. A and B don't really matter. I'm going to always start off with just Pythagorean theorem. So a squared plus b squared is equal to c squared. So 9 squared is 81 plus 12 squared is 144, and that could possibly equal to 15 squared, which is 225. So 81 plus 144, and I'm putting it in my calculator because I'm being lazy, is 225. So 225 is equal to 225. So if this is true, then that means this is a right triangle. And really, maybe you noticed that it was a variation of 3, 4, and 5, but we wanted to work it out because it says justify your answer. Okay, so this is a right triangle because 225 is equal to 225. And then our last slide says determine whether 10, 11, and 13 can be the measure of the sides of a triangle. If so, classify the triangles acute, right, or obtuse. Justify your answer. So 10 is A, 11 is B, 13 is C. So I'm going to do 10 squared plus 11 squared is equal to 13 squared. So 10 squared is 100, plus 11 squared is 121, and is that equal to 13 squared, which is 169. So 100 plus 121 gives me 221, and 221 is not equal to 169, but 221 is greater than 169. So that means I have a squared plus b squared is greater than c squared, and when the sum is greater, then my triangle is acute. When the sum is greater, my triangle is acute. And that's it. That's all she wrote. I know this was kind of lengthy, but you have a lot of new information that you can use to process for future assignments. Have a good one.